Good afternoon, everyone. In this presentation, we want to show our project tilted smoke detect and temperature monitoring system with Arduino. The main purpose is to design a device capable of identifying the presence of smoke in the environment and simultaneously measuring temperature in real time using an LM35 sensor. The motivation arises from recognizing that my fires in home and small business begin with it, which great increase that damage. For the reason we seek to develop an economical, reliable and accessible solution, especially for space that don't have advanced security systems or prototype use components that are easy to arcade intuitive assemble. Ideal both for preventing incidents and for education purpose.
The prediction of system is based on two main sensors connected to the Arduino. First, the smoke sensors analyzes the concentration of particles present in the air when these particles exceed a set level, that is, when there are sinks of smoke, the sensor sends an analog signal to the Arduino. The microcontroller evaluates this signal and if it surpasses the programmed threshold, it immediately activates and leads. At the same time, the LM35 sensor records the ambient temperature with high linear precision. The Arduino receives its analog output and displays the temperature values in real time. In this way, the system combines smoke detection and thermal monitoring, two key variables for warning of a possible early stage fire. The ultimate goal is to offer a fast, automated, and low-cost response to potentially dangerous situations.
This project is designed to benefit a wide variety of space. First, it is ideal for homes, shops, restaurants, study rooms, electrical rooms, laboratory, parking lots, and in general in any environment where a fire could start with constant supervision. It is also an excellent tool for education institution as, as it can serve an academic prototype for students who wish to learn about basic electronics, analyze sensor signal processing, and Arduino programming. Thanks to its low cost and easy of implementation, it is accessible to communities that cannot afford high-priced commercial equipment. This makes the system a functionality alternative to improving preventive safety in vulnerable environments.
For the development of the project, we used several fundamental electronic components including Arduino Uno, which functions as the main controller, a smoke sensor responsible for detecting particles and gases, LM35 sensor used to measure temperature in a linear and precise manner, buzzer or alarm, which generates the audible warning signal, redlet as an additional visual indicator, breadboard, resistors, and DuPont wires necessary for connection and circuit protection. The assembly the assembly began by organizing the Arduino and the breadboard, then the smoke sensor was connected to the power lines and the analog reading pin. After that, the buzzer and LED were integrated into digital pins, programming the activation limits. Finally, controlled tests were carried out by bringing a small source of smoke close to the system to verify its reaction and properly calibrate the alert threshold.
The project also has direct relationship with mathematical concept, particularly with linear algebra. The LM35 sensor exhibits linear behavior. As its output is described, by function of the form.
V equal K by T, where V is the voltage produced and T the measured temperature. K is a proportionally constant. This type of expression is recognized as a linear transformation because it maintains K properties such as proportionality and additivity. In other words, if the temperature doubles, the voltage also doubles. Thanks to this linearity, the Arduino can easily convert the analog signal from the LM35 into degrees Celsius using a simple linear equation. In addition, signal analysis, threshold, and comparison are handled within the vector space of the real numbers, where the sensor values are interpreted as scalars. Without these linear properties, interpreting the sensor data and turning it into useful information would be much more complex.
In conclusion, we can affirm that it is completely feasible to build an early smoke detection system completed by temperature monitoring using Arduino. The prototype responded correctly to the presence of smoke, activated the alarm, and provided accurate temperature readings, allowing users to anticipate risky situations. Additionally, the design is catchable. It can be improved by integrating Wi-Fi connections, Bluetooth communication, mobile phone alerts, or even automations to turn on fans and activate sprinklers. Overall, this project represents an economical, functional, and accessible solution to improve safety in different smart environments, demonstrating the potential of basic electronics and programming as preventive tools. Thank you very much for joining us in these presentations.
Hey, but this isn't the finish. Right now, I'm going to explain this in Spanish. Principalmente, este proyecto consiste en un sistema capaz de detectar niveles peligrosos de gases, en este caso sería humo, mediante un sensor MQ5 y medir la temperatura ambiente usando un sensor LM35. La información se procesa en un Arduino 1, el cual libera un LED, activa un LED cuando la temperatura supera cierto nivel y envía mensajes al monitor serial cuando el gas o el humo alcanza niveles críticos. El objetivo principal es mostrar cómo un circuito sencillo puede monitorear dos variables importantes para seguridad, gas y temperatura. En este proyecto utilizamos un Arduino 1, un microcontrolador, principalmente es un microcontrolador ATmega328P. Lo que hace el Arduino 1 es convertir las señales analógicas a digitales con un ADC de 10 bits. O sea, que cualquier entrada analógica se convierte en valores de 0 a 1023. También usamos un sensor MQ5, que es el que parece un colador y es el que detecta el humo. El MQ5 detecta concentraciones de gases combustibles como gas LP, hidrógeno o metano. Internamente funciona de tal manera que tiene un material semiconductor calentado por una resistencia interna. Cuando hay gas alrededor, su resistencia interna cambia. Ese cambio de resistencia se convierte en un voltaje analógico que el Arduino lee. La interpretación del MQ5 se interpreta bajo valores bajos de 0 a 350, que es el ambiente normal, medios de 350 a 450, posible presencia de gas, y altos, que son de 450 en adelante, que es un nivel riesgoso. El ADC del Arduino toma este voltaje y lo convierte en un número. El programa evalúa si este número supera el umbral o el nivel para activar la alerta. También en el proyecto usamos un sensor LM35 de temperatura. El LM35 es un sensor de temperatura lineal, lo que significa que cada cambio de temperatura produce un cambio proporcional del voltaje. El Arduino lo interpreta de tal manera que el LM35 le entrega un voltaje. El Arduino convierte ese voltaje en un número entre 0 y 1023 usando su ADC. El LM35 es completamente lineal. lo que significa que su ecuación se basa en la transformación lineal. Como anteriormente en el video aplicamos, que dice que entre la temperatura sube, el voltaje también sube. En el LM35 se utiliza la ecuación B igual a K por T, siendo B voltaje, T temperatura y K la constante. La conversión del LM35 es una transformación lineal entre el espacio de voltajes y el espacio de temperaturas. En conclusión, el MQ5 mide la presencia de gas y entrega un voltaje proporcional. El Arduino convierte ese voltaje a un valor de 0 a 1023. Si el valor supera los 400, se activa la alerta en el serial. El LM35 mide la temperatura y el ADC convierte su señal. Mediante álgebra lineal se pasa a la lectura digital a grados Celsius. Si la temperatura excede 25 Celsius, el LED se enciende. Este proyecto muestra un sistema de monitoreo fiable, económico y escalable, capaz de detectar condiciones de riesgo en tiempo real usando principios de electrónica analógica, transformaciones lineales, adquisición de datos analógicos, lógica programable y microcontroladores. Demuestra cómo integrar sensores analógicos en un sistema embedido y cómo aplicar matemáticas reales, en este caso el álgebra lineal, en ingeniería.